Hello students and good morning. So now I am doing class for class 10. The topic is sphere. So in the last online class also we were doing this same chapter, that is sphere, and we did some problems in that online class. So today we'll do again this chapter, that is sphere. Exercise 12, page number 184 from the book Ganit Prakash for class 10 by West Bengal Board of Secondary Education. So now let's do this question number 12. Two hollow spheres with lengths of diameter 21 centimeter and 17.5 centimeter respectively are made from the sheets of the same metal. So in this case, what is asked in the question is that two hollow spheres are made from the sheets of same metal with length of diameter 21 centimeter and 17.5 centimeter. So that is, what is the length of diameter of the first hollow sphere? It is 21 centimeter. And what is the length of diameter of the second hollow sphere? That is 17.5 centimeter. So they are given. बुझ्दैछ? यहाँ दुईटा hollow sphere छ. Hollow sphere भनेको भित्र के पनि नभएको खोक्रो, भित्र के पनि नभएकोलाई के भन्छ हामी? खोक्रो भनेर भन्छ, भित्र के पनि छैन. So two hollow spheres are made from the sheets of same metal. The first hollow sphere को length of diameter कति छ? 21 centimeter. अनि second hollow sphere को diameter कति छ? 17.5 centimeter. So now what is asked in the question? Let us calculate the ratio of surface area of the sheets of metal required to make the two spheres. So यो दुईटा spheres बनाउनलाई you have to find out the ratio of the surface areas of the sheets of metal that is required to make the two hollow spheres. So you have to find out the ratio of the surface areas of the two hollow spheres. So I think you have understood the question. So let's do this problem now. So the solution is, now let's do the solution. What is the length of the diameter of the first hollow sphere? So let us write down diameter of the first sphere. So what is the diameter of the first sphere? It is 21 centimeter. Okay, so you have to find out the radius in order to get the surface area of the sphere, right? So let us get its radius. So its radius is equal to 21 upon 2 centimeter. So let us keep it as it is, right? So this is 21 by 2 centimeter. Don't simplify it, right? So similarly, what is the diameter of the second sphere? Diameter of the second sphere is equal to, how much is that? It is 17.5 centimeter. So its radius is equal to 17.5 divided by 2 centimeter. Okay, so we have calculated their radii, right? So now let us find out the surface area. Let us find out their surface areas. So surface area of the first sphere. So surface area of the first sphere is equal to, that means you have to find out the curved surface area of the sphere. बाहिरपट्टिको area निकाल्नु पर्यो. So what is the formula for curved surface area of the sphere? It is 4 pi r square. You know that, right? 4 pi r square, which is equal to 4 pi, keep it as it is. What is r? What is the radius of the first sphere? It is 21 by 2. So this is 21 by 2 whole square. What is the unit? This is square centimeter. Area means square centimeter. The unit is square centimeter. Is that clear? So this is the surface area of the first sphere. Now let us calculate the surface area of the second sphere. So therefore, surface area of the second sphere is equal to, what is the formula again? It is 4 pi r square which is equal to 4 pi. What is r whole square? That is, it is 17.5 by 2 whole square. So this is the surface area of the second sphere. So what is this unit? It is also square centimeter. Is that clear now? So what is asked in the question? You have to find out the ratio of the surface areas of the two hollow spheres. So यो दुईटा स्फियर को चाहिँ हामीले के निकाल्नु पर्छ? यो दुईटा स्फियर को सर्फेस एरिया को चाहिँ के निकाल्नु पर्यो? रेशियो निकाल्नु पर्छ. ठीक छ? So ratio of surface areas. Now let us calculate the ratio of surface areas of the two hollow spheres. So therefore ratio of surface areas of two hollow spheres is equal to, two hollow spheres means first sphere is to second sphere, right? So it is first sphere is to second sphere, which is equal to, what is the total, what is the surface area of the first sphere? It is 4 pi. It is 4 pi 21 by 2 whole square is to, for second sphere, what is the surface area of the second sphere? It is 4 pi 17.5 by 2 whole square. So let us write there 4 pi. So this is 17.5 by 2 whole square. So I think you have understood it. So let us simplify it. In the ratio, in terms of ratio, you can cancel the similar term in both these terms. That is, this is known as antecedent and this is known as consequent. You know that in ratio, this first part is known as the antecedent and this second part is known as the consequent, right? So here this 4 pi gets cancelled. Cancel them. So 21 by 2 whole square means 21 by 2. You have to write it 2 times. 21 by 2 is 2. Next. What is 17.5 by 2 whole square? This is similarly 17.5 by 2 into 17.5 by 2. So in both the sides you can cancel the similar terms. You can cancel it. 2 gets cancels. Here 2 gets cancelled. This 4. Same numbers are there in both antecedent and in consequent. So in the denominator you can cancel this similar terms. So again you have to write 21 into 21 is to, what is 17.5? 175 divided by 10 into 175 divided by 10. That is, this decimal is converted into fraction. So 17.5 means 175 divided by 10 into this 17.5 is again 175 divided by 10. So you know how to write down decimal in terms of fraction, right? So let us simplify it. So you can cancel here. You can cancel it by 5. This is 5 2s are 10. 5 lela kati times? 5 3s are 15. 5 5s are 25. Here also 5 2s are 10. 5 3s are 15. 25. 5 5s are 25. Right? So which is equal to 21 into 21 is to 35 by 2 into, this is 35 by 2. Again, in case of ratio, you can cancel the term which are in the numerator. You can cancel the similar terms which are in the numerator from both antecedent and consequent, right? So you can cancel it by 7. 7 3s are 21. 7 5s are 35. 7 3s are 21. 7 5s are 35. So which is equal to, what is 3 3s are? 9 is 2. This is 25 by 2 2s are 4. But in this case, we are getting this consequent as fraction. So you have to convert into whole number, right? So what is the method of converting this 25 by 4 into whole number? So below 9 there is 1 and below 25 there is 4. So what is the LCM of 1 and 4? You have to get the LCM of this denominator. So what is the LCM of 1 and 4? This is 4. So you have to multiply both these numbers by 4 in order to cancel this denominator 4. So which is equal to 9 into 4 is to 25 by 4 into 4. Here 4 gets cancels. This is 9 4s are 36 is to this is 25. So what is the ratio of surface areas of the two spheres? It is 36 is to 25. So this is the final answer. So I think you have understood it. So this is the calculation that you should do it. Okay, you should know all this calculation, right? So after calculation, we got the answer as 36 is to 25. So I think you have understood it. You can copy it. Now we'll do the next problem. So now we will do the next question, that is question number 11. So this question number 11 is very, very important. Okay, so you can mark it as important problem, right? So question number 11 is the curved surface area of a solid metal sphere is cut in such a way that the curved surface area of the new sphere is half of that of the previous one. तो यहाँ के भन्दैछ भन्दाखेरि the curved surface area of a sphere is cut in such a way that the curved surface area of the new sphere is half of that of the previous one. The एउटा sphere छ, त्यो sphere को curved surface area यस्तो पाराले काटियो. त जुन चाहिँ new sphere form हुँदैछ, त्यो new sphere को curved surface area चाहिँ पुरानो sphere को भन्दा के छ, half छ. पुरानो sphere को curved surface भन्दा के छ, आधी छ. ठीक छ? त एउटा स्फियर छ, त्यो स्फियर को कर्व सर्फेस एरिया यस्तो पाराले काटियो. जब त्यो न्यू स्फियर फर्म हुन्छ, न्यू स्फियर बनिन्छ, त्यो न्यू स्फियर को कर्व सर्फेस एरिया चाहिँ पुरानो स्फियर को कर्व सर्फेस एरिया को चाहिँ आधी हुन्छ भनेर क्वेशनले भन्दैछ. Is that clear? I think I have understood it. Okay. So now let us calculate the ratio of the volume of the sphere. Let us calculate the volume. Let us calculate the ratio of the volume of the portion cut off and the remaining portion of the sphere. So in this case, you have to find out the ratio of the volume of the sphere cut off and the remaining portion of the sphere. त तिमीले यहाँ के को रेशियो निकाल्नु पर्ने रहेछ? You have to calculate the ratio of the volume of the portion cut off and the remaining portion of the sphere, right? त यहाँ म एउटा नक्सा बनाएर बुझाउने चेष्टा गर्दै छु. Suppose यो के हो, sphere. This is a sphere, right? एउटा sphere हो. एउटा sphere भयो. त यो sphere को यो जुन चाहिँ sphere, यो चाहिँ sphere चाहिँ के भयो? Old sphere or original sphere. यो चाहिँ original sphere or old sphere. त यो old sphere को कर्व सर्फेस एरिया भनेको बाहिरपट्टिको एरिया यस्तो पाराले काटियो. सपोज यहाँ काटे हेर यसरी. यो काटेको पर्छ है, ठीक छ? यो चाहिँ काट्यो हेर सपोज. The curved surface area of the sphere is cut off. Okay? The curved surface area of the sphere is cut off in such a way that the curved surface area of the new sphere is half of that of the curved surface of the old sphere. So, अब यो कट अफ गरेपछि फेरि अझ एउटा न्यू स्फियर फर्म भयो. त्यो जुन चाहिँ पोर्सन कट अफ भयो, ठीक छ? त्यो जुन चाहिँ पोर्सन कट अफ भयो, त्यो पोर्सन काटेको पोर्सन जुन चाहिँ छ, त्यसको कर्व सर्फेस एरिया चाहिँ इट इज हाफ अफ दैट अफ द ओल्ड वन. पुरानोको भन्दा चाहिँ यो नयाँको कर्व सर्फेस एरिया चाहिँ के छ, आधी छ भनेर भन्दैछ. So now you have to find out the ratio of the volume of the portion cut off and the remaining portion of the sphere. The यो दुईटाको volume को ratio चाहिँ निकाल्नु पर्छ. कस्तो खाले ratio भन्दाखेरि you have to calculate the ratio of the volume of the portion cut off and the remaining portion of the sphere. So I think I understood it. So let us do this problem now. Now in this case, The curved surface area of the solid sphere is cut in such a way that the curved surface area of the new sphere is half of that of the old sphere. So let us assume the radius of the old sphere as well as radius of the new sphere. Okay. So now this is the solution. Let the radius of the old sphere be R1. Okay. So old sphere को radius चाहिँ कति रहेछ R1 भनेर हामीले सपोज गर्यौं. अब न्यू स्फियर को पनि सपोज गरौं. Let the radius of the new sphere be R2. Let the radius of the new sphere be R2. Now what is to be calculated? अब हामीले के क्याल्कुलेट गर्छ यसको surface area. यहाँ surface area, curved surface area कुरा आउँदैछ. Let us find out the curved surface area of the old sphere. Therefore, curved surface area of the old sphere. Curved surface area of the old sphere is equal to, what is the formula? For old sphere, what is the radius R1? So it is 4 pi R1 square. Is that clear? So now, similarly, what will be the curved surface area of the new sphere? Therefore, curved surface area of the new sphere is equal to, how much is that? 4 pi R2 square, because in this case R2 is the radius of the new sphere. Okay. Now by question, a condition is given there. The curved surface area of the new sphere is equal to half of the curved surface area of the old sphere. Okay. So now by question, let us write here. By question, curved surface area of new sphere is equal to, this is the continuation line, okay, is equal to curved surface area of old sphere. Curved surface area of old sphere. So, or what is curved surface area of the new sphere? Curved surface area of the new sphere is 4 pi R2 square. So this is 4 pi R2 square is equal to, it's not is equal to half. Curved surface area of the new sphere. By question it is given that curved surface area of the new sphere is half of the previous one. That is equal to, this will be half into, right? Sorry, I have forgotten it. It is half into curved surface area, right? By question it is given that the curved surface area of the new sphere is half of that of the previous one. That means by question, curved surface area of the new sphere is equal to half into curved surface area of the old sphere, right? So, or now this one becomes, what is the curved surface area of the new sphere? It is 4 pi R2 square. This is 4 pi R2 square is equal to half into, what is the curved surface area of the old sphere? That is 4 pi R1 square. 4 pi R1 square. Okay. So you can cancel a similar term from both the sides. So if you cross multiply it, you will get R1 square is equal to 2 R2 square. So let us get the value for R1 only. What is R1? Or R1 is equal to root over 2 R2. So let us mark it as number 1. So I think you have understood it, this relation. So how did we get this relation? I think you have understood it. So this is R1 is equal to root over 2 into R2. Okay. So now what is to be calculated? Let us calculate the ratio of the volume of the portion cut off and the remaining portion of the sphere. You have to find out the ratio of the volume of the portion cut off and the remaining portion of the sphere. Okay. So now let us find out the volume of the whole sphere. So since radius of the whole sphere is r1, what is the volume of the whole sphere? So therefore, volume of the whole sphere is equal to, since r1 is the radius of the whole sphere, what is the formula? Volume of the whole sphere is equal to 4/3 pi r1 cube. 4/3 pi r1 cube. This is the volume of the whole sphere, right? Next, what is the volume of the new sphere? Therefore, let us find out volume of the new sphere. Volume of the new sphere. What is the volume of the new sphere? The new sphere radius is r2. So what is this volume? It is 4/3 pi r2 cube. 4/3 pi r2 cube. I think you have understood it. So this volume of the new sphere means volume of the remaining portion. Volume of the new sphere means this is the volume of the remaining portion. Now, what is the volume of the portion cut off? So what is the volume of the portion cut off? That is volume of the whole sphere minus volume of the new sphere will give you the volume of the portion cut off. कति चाहिँ काटिएको थियो भन्दाखेरि कति volume चाहिँ काटिएको थियो भन्दाखेरि volume of the whole sphere minus volume of the new sphere. That is volume of the portion cut off. Therefore, volume of the portion cut off, volume of the portion cut off is equal to volume of the whole sphere minus volume of the new sphere. What is the volume of the whole sphere? This is 4/3 pi r1 cube minus 4/3 pi r2 cube. Understood? So what is common out here? 4/3 pi is common out here. So within bracket r1 cube minus r2 cube. I think understood? You have understood it? So next you can put the value for r1 out here. What is the value for r1? Root over 2 r2. So which is equal to 4/3 pi. Now within second bracket put the value for r1 here. What is r1? Root over 2 r2 whole cube minus r2 cube remains as it is. So which is equal to 4/3 pi. Now within bracket, what is root over 2 whole cube? You know from sorts. What is root 2 whole cube? Root over 2 whole cube means root 2 into root 2 into root 2. Root 2 whole cube means root over 2 is multiplied thrice. That is root 2 into root 2 into root 2. So what is root 2 into root 2? That is your 2. So root 2 remains as it is. That is root over 2 whole cube means 2 root 2. So here it is 2 root 2 r2 cube minus r2 cube. Bracket closed. So what is common out here? You can take common here. So which is equal to 4/3 pi within bracket 2 root 2 minus 1. Then you can write here r2 cube. So this is the volume of the portion cut off. So what is meant by volume of the remaining portion? Volume of the remaining portion means this volume of the new sphere. This volume of the new sphere means volume of the remaining portion. Is that clear? So let us calculate the ratio of the volume of the portion cut off and the remaining portion of the sphere. Here the volume of the remaining portion of the sphere means volume of the new sphere. That is 4/3 pi r2 cube. Okay? So let us find out the ratio now. So let us write down here required ratio is equal to, therefore required ratio is equal to volume of the portion cut off, volume of the portion, right? Volume of the portion cut off is to volume of the remaining portion. Volume of the remaining portion. Volume of the remaining portion. So which is equal to, what is the volume of the portion cut off out here? This one. Let us write this one 4/3 pi. 4/3 pi within bracket 2 root 2 minus 1 bracket closed. This is R2 cube is 2. What is the volume of the remaining portion? That is the volume of the remaining sphere. This is the volume of the remaining portion, that is 4/3 pi R2 cube. This is 4/3 pi R2 cube. So in this case, antecedent is to consequent. So in terms of ratio, you can cancel the similar terms from both antecedent as well as consequent. So you can cancel these similar terms. This R2 cube also gets cancelled, which is equal to 2 root 2 minus 1 is to 1. So this is the final answer. So this question is very, very important, right? So I think I understood it. So you can copy it. Now we'll do the next question. Now we'll do the next question, that is question number 13. On the curved surface of the axis of a globe with the length of 14 centimeter radius, two circular holes are made, each of which has the length of radius 0.7 centimeter. तो यहाँ ग्लोब को कुरा आउँदैछ, तिमीले सायद ग्लोब देखेको छौ होला, जियोग्राफी क्लासमा तिमीले ग्लोब देखेको हुनुपर्छ हैन? टिचरले, जियोग्राफी टिचरले एउटा ग्लोब लिएर आएर तिमीलाई पढाउनु हुन्छ। त्यो ग्लोब कस्तो शेपमा हुन्छ? स्फियरको शेपमा हुन्छ, ठीक छ? त त्यो ग्लोब जुन चाहिँ ग्लोब छ त्यसको रेडियस चाहिँ कति रहेछ? इट इज 14 सेन्टिमिटर। अनि त्यो ग्लोबमा एक्सिस पनि बनाएको हुन्छ, त्यो एक्सिस चाहिँ एउटा होलदेखि छेडेर अर्को होलबाट निस्किन्छ त्यो एक्सिस, ठीक छ? त त्यो एक्सिसको लागि दुईटा सर्कुलर होल्स बनाउनु छ, एउटा माथि एउटा ठिक त्यसको तलपट्टि बनाउनु पर्छ, सर्कुलर होल्स। तो दुईटा सर्कुलर होल्स बनाउनु पर्छ, त्यसको लागि यो दुईटा सर्कुलर होल्सको रेडियस चाहिँ कति रहेछ? 0.7 सेन्टिमिटर। एउटा माथि सर्कुलर हुन्छ, एउटा तल सर्कुलर हुन्छ, so that the axis can pass through that holes, right? So what is the radius of these two circular holes? It is 0.7 centimeter. Is that clear? Next, you have to calculate the area of the metal sheet required for surrounding its curved surface. So you have to find out the area of the metal sheet. That is, you have to find out the area of the metal sheet that is required for surrounding its curved surface. You have to find out the area of the metal sheet that is required for surrounding its curved surface. Is that clear to all of you? So let us do this solution. तो त्यो होललाई त छोप्नु परेन, त्यो होलको एरिया चाहिँ होल एरियाबाट चाहिँ के गर्नुपर्छ? माइनस गर्नु पर्यो, घटाउनु पर्छ, ठीक छ? नाउ solution is, so let us do this solution. Now let us find out the surface area of the globe first. So what is the radius? Radius of the globe. Radius of the globe. So radius of the globe is, how much is that? 14 centimeter. Radius is given. Radius of the globe is 14 centimeter, right? So let us find out its curved surface area. Curved surface area is equal to, what is the formula? 4 pi r square, which is equal to 4 into, what is pi? This is 22 by 7. You know the formula for pi, which is 22 by 7. And what is radius whole square? It is 14 whole square, right? So let us simplify it. 4 into 22 by 7 into, what is 14 whole square? It is 14 multiplied by 14. It is 14 multiplied by 14. 7 1s are 7, 7 2s are 14. You can cancel it. So 4 into 22, that is 88, into 2 into 14, that is 28, right? So let us multiply it again. That is 88 multiplied by 28. So 28 is multiplied by 88, right? So let us multiply them. 8 8s are 64. 4, 6, 8 2s are 16 plus 6. 16 plus 6 is 22. 8 8s are 64. 4, 6, 8 2s are 16 plus 6 is 22. So which is 4, 4 plus 2 is 6, 2 plus 2, 4, 2. That is 2464. So which is equal to 2464. What is this unit? It is square centimeter. It is square centimeter. Okay? But there are two holes for the axis of the globe, isn't it? For the two holes, these two circular holes are made. The two circular holes are made, each of which has the radius of 0.7 centimeter. That two holes, दुईटा होल बनाए चाहिँ एउटा माथिपट्टि एउटा तलपट्टि, त्यो होलको एरिया चाहिँ के गर्नुपर्छ, योबाट माइनस गर्नुपर्छ. Then only you can get the area of the metal sheet that is required to make the globe, right? So let us write down area of each hole. So let us write radius of each hole first. Radius of each hole is equal to, what is the radius of each hole? It is 0.7 centimeter. 0.7 centimeter. Let us find out this area. It is of circular shape. Circular shape means, what is the area of the circle? It is pi r square. You should know that. In class 9 you did circle, isn't it? What is the area of the circle? It is pi r square. So therefore area of each circular hole or area of each hole is equal to, what is the formula? Pi r square, which is equal to 22 by 7 into, what is r whole square? It is 0.7 whole square. So let us simplify it, which is equal to 22 by 7 into 0.7 into 0.7, right? So you can cancel here, 7 ones are 7, this is 0.1, right? So this is your 0.1. You can cancel 0.7 by 7. So which is equal to, let us multiply it. This is 22 into, actually it is 7 into 1 is 7. 7 ones are 7. Now where will you write down the decimal point? After decimal point there is one figure. Here also after decimal point there is one figure. 1 plus 1 is 2. So you have to write down decimal point before two figures from the end. That is 7, and you should put 0 here, then you should write point here. Okay? So 0.7 into 0.1, that means 0.07. So what is 22 multiplied by 0.07, which is equal to 7 2s are 14. 4, 1, 7 2s are 14 plus 1 is 15. So here after decimal point there are two figures. You should write down decimal point before two figures from the end. That is 1.54. What is the unit here? It is square centimeter. So this is the area of each hole. But there are two holes there. So what is the area of two holes? You have to multiply it by 2, right? So area of two holes is equal to 1.54 multiplied by 2, which is equal to 4 2s are 8, 2 5s are 10, 1 2 1s are 2 plus 1 is 3. 2 4s are 8, 2 5s are 10, 0, 1, 2 1s are 2 plus 1 is 3. And after decimal point there are two figures. So you have to write down decimal point before two figures from the end. That is 3.08. What is the unit? It is square centimeter. So now you have to find out the area of the metal sheet. You have to find out the area of the metal sheet surrounding its curved surface. That means this total area minus this area will give you the area of the metal sheet required for surrounding its curved surface. Okay? So therefore, now let us write down area of metal sheet. Area of metal sheet required for surrounding curved surface. Required for surrounding curved surface. Required for surrounding curved surface is equal to, this whole area is 2464 minus 3.08. So in 2464 there is no decimal point. Where is the decimal point here? Decimal point is after the number, that is point is out here. Okay? Now 3.08 should be subtracted from 2464. That is 3, after decimal point there is decimal point 08. Okay? So you 3.08 लेख्दाखेरि यो पोइन्टको तल पोइन्टै आउँछ त यो पोइन्टको पछाडि 08 यो पोइन्टको पछि 08 अगाडिपट्टि के लेख्छ 3 लेख्छ so you can add here 0 0 okay now we can subtract it so you can subtract it now so how much is it 10 minus 8 is 2 this is your 9 point this is 3 minus 3 is 0 6 4 2 so this is the area of the metal sheet required for surrounding the curved surface of the globe so this is square centimeter so what is the area of the curved surface that is required for surrounding the curved surface area of the globe that is 2460.92 square centimeter so this is the final answer so I think you have understood it so you can copy it now we'll do the next question that is question number 14 So now we'll do the next question that is question number 14 so let us write by calculating how many marbles with length of 1 centimeter radius may be formed by melting a solid sphere of iron having 8 centimeter length of radius so in the question it is asked to find out how many marbles each of radius 1 centimeter can be formed by melting a solid sphere of radius 8 centimeter radius by melting a solid sphere of iron having 8 centimeter length of radius त एउटा solid sphere छ जसको radius को length छ 8 centimeter त्यसलाई मेल्ट गर्दैछ त्यसलाई गलाउँदैछ त्यसलाई गलाएर सानो marbles जसको प्रत्येकको रेडियस कति छ 1 सेन्टिमिटर छ त यस्तो टाइपको मार्बल्सहरु हामी कतिवटा बनाउन सक्छौ भनेर सोध्दैछ हाउ मेनी मार्बल्स each of radius 1 centimeter can be formed by melting a solid sphere of iron having the length of radius 8 centimeter in length is that clear so let us find out the solution so the solution here is so now radius of the solid sphere radius of the solid sphere radius of the solid sphere is equal to this is 8 centimeter now in this case how many marbles can you form how many marbles can you form from solid sphere of radius 8 centimeter right so in this case how many marbles you have to find out the number of marbles that can be formed so in this case you have to find out the volume of the solid sphere so therefore volume of the solid sphere so volume of the solid sphere so volume of the solid sphere is equal to what is the formula it is 4/3 pi r cube right so keep it as it is 4/3 pi what is r whole cube that is 8 whole cube then it is cubic centimeter right so this is the volume of the solid sphere त यसलाई गलाएर चाहिँ सानो मार्बल्सहरु बनाइदैछ जसको प्रत्येकको मार्बलको रेडियस चाहिँ कति रहेछ 1 सेन्टिमिटर let us find out the volume of each marble so here also you have to find out the volume of each marble is equal to what is the formula again this is 4/3 pi r cube which is equal to 4/3 pi what is r here what is the radius of each marble that is your 1 isn't it 1 so this is 1 whole cube so this is only 4/3 pi what is the unit here this is cubic centimeter so how can you find out the number of marbles that can be formed that is there is a formula volume of the marbles that can be formed is equal to volume of the solid sphere divided by volume of each marble so therefore number of marbles is equal to what is the formula volume of solid sphere divided by volume of each marble. Volume of each marble, right? So number of marbles is equal to, what is the formula? Volume of the solid sphere divided by volume of each marble. So which is equal to, what is the volume of solid sphere? Volume of solid sphere is equal to 4/3 pi 8 whole cube whole divided by, what is the volume of each marble? Volume of each marble, what is the volume of each marble? It is 4/3. It is 4/3 pi 1 whole cube. So here you can cancel this. 4/3 pi gets cancels, which is equal to 8 into 8 into 8. 8 whole cube means 8 into 8 into 8 divided by 1 whole cube means 1 into 1 into 1. So which is equal to, what is 8 into 8 into 8? You know that 8 is 64 into 8 divided by 1. If the denominator is 1, you don't have to write it. So which is equal to 8 4s are 32, 3. 8 6 are 48 plus 3 is 51. So this is 512. So this is the answer. So how many marbles can be formed from the solid sphere of radius 8 centimeter? So 512 marbles can be formed. So how many marbles can be formed? 512 marbles can be formed from a solid sphere of iron having 8 centimeter length of radius. So this is the final answer. So I think I've understood it. So you can copy it. So this much is for today. त आज हामीले 4टा मात्रै प्रब्लम गर्यौं. यो 4टै प्रब्लम घरमा रिभिजन गर्नु. जति पनि यो स्पेयरमा तिमीले प्रब्लमहरु गरेका छौ सबै नै रिभिजन गर्नु, so that it will be easier for you to do the problems in the next class. Okay, यो सबै रिभिजन गरेपछि तिमीलाई नेक्स्ट क्लासमा अझै सजिलो हुँदै जान्छ. So this much is for today.